Alright, today we're going to be going over sums of consecutive differences. So to start, we're going to go over the formula of what this will look like. So we have our sum symbol, which is this little e thing with an n on the top and an I on the bottom of di. So this is the same as the normal formula, which you've probably seen if you looked at this before, which is d of n multiplied by n plus 1 all divided by 2. But if you're wondering what any of that means, we're going to go over it. So n is going to be the final term number, but not the value of it. So for example, we have our little example here of counting up by threes. So our first term is going to be 3, our second term 6, third is 9, fourth is 12, and the fifth is 15. So our n in this case is going to be our last term, which is going to be 15. But it's not going to be the value of our last term, it's going to be the number of the last term. So our n, instead of being 15, our n is going to be 5. And our d is going to be the difference between the terms. So what you can do here is you can take your second term and subtract it by your first term. So we'll have 6 minus 3, which will give you 3. And you can see that since we're counting up by threes, the difference between our terms is going to be 3. Now, if you do the difference first, a way that you could figure out your n value is by taking your last known number, which for this case is 15, and dividing it by the difference. So this will give us the same answer of 5. It just depends on whichever way you like doing better. So if we had an example here of our d of n multiplied by n plus 1 all divided by 2, and we'll use our example of counting up by threes, we'll set it up as this d, so that's 3, multiplied by our last term, which is 5, multiplied by our last term, which is our 5, plus 1, which will give us 6, all divided by 2, which will give us 45, which you can check after by doing 3 plus 6 plus 9 plus 12 plus 15. Since we only have 5 numbers, it's easier to do, which will give us an answer which matches of 45. Alright, now our second example is going to be counting up by ones all the way to 100. So before writing the formula down and making it all confusing, we're going to just start off by writing d is equal and n is equal. So what this means is we're just going to find out what our two variables of d and n will equal to first, and then when we put it into the formula, we already have all the information we need. So we can see here that this is counting up by ones, because 1 plus 1 is 2, plus 1 is 3, and the dot 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 means it's just following the same pattern all the way up to 100, which means that our difference is going to be 1, and our n is going to be our last term. But since it's counting up by ones, our term is going to be the same as the value, because there's no multiplied, because you could do 100 like we did before, divided by our d, which in this case is just 1, which gives us 100 back. So our n is still going to be 100. Now that that's all done, we can put it into our formula of d of n multiplied by n plus 1 all divided by 2, which will give us 1 multiplied by 100 multiplied by n plus 1, which is 100 plus 1, so 101, all divided by 2, which if you put it into a calculator will give us 1 times 100 times 101 divided by 2 will give us 5,050. Alright, now we have our last question of the video, which is going to be counting up by twos all the way to 2,000. So we're going to follow the same steps as we did on the last question. We're going to find our d first, and then we'll find our n after. So our d is just going to be, for a reminder, the difference between all your terms, which as you can see here, we're counting up by twos, so our difference is going to be 2. And now we're going to find our n. And our n, if you remember, is just our final term value. So that's going to be 2,000 divided by d, or it's just going to be the number of the final term, not the value. So for this one, it's going to be 2,000 divided by 2, which gives us our final term number of 1,000. So we know that this goes from term 1 to term 1,000. And now we're able to put it into the formula, which will give us d multiplied by n multiplied by n plus 1, and all of that divided by 2. Now putting in our numbers, we get a d of 2, and then n and n plus 1, giving us 1000 multiplied by 1001, all divided by 2, which will give us 2 times 1000 multiplied by 1001 divided by 2, giving us a final answer of 1,001,000. And if you ever want to check your answer, you're going to set your first one as equals to 2, and then next up is going to be A1, which is going to be our one before, plus 2, since we're counting up by 2's. Now all you have to do is bring your mouse over so that it turns to a black cross and carry it down, and it'll keep counting up by 2's. And since we know from our question that our term value is 1000, what we're going to do is we're going to wait and drag it all the way down until we see the number on the side equaling our term number of 1000. And to check our answer, we can see that it does equal to 2000 as the 1000th term, and all we have to do is put an equal sign, and then we have the sum of A1, because that's our first square, and then the colon, and then A1000, end bracket, and it will tell us the same answer of 1,001,000.